Welcome to Digital Dynamo Lab. In this video, we will learn about logic gates. What is a logic gate? A logic gate is the basic building block of any digital system. It is an electronic circuit having one or more than one input and only one output. The relationship between the input and the output is based on a certain logic. This AND gate, OR gate and NOT gate are basic types of logic gates. There are 7 types of logic gates, which we will discuss in this video along with the truth table. Following are the types of logic gates with their symbolic representation: AND gate, OR gate, NOT gate, NOR gate, NAND gate, exclusive OR gate, exclusive NOR gate. Let's start with first gate, which is OR gate. This is how OR gate is represented. OR gate has 2 inputs and 1 output. The usually digital signals are represented in zeros and ones. 0 indicates no digital signals and 1 indicates digital signal. Let's see the truth table for OR gate. OR gates has 2 inputs. Therefore, we can name A and B, and output we will name Y. There can be 4 possible inputs. First input can be A equals 0 and B equals 0. There is no signal in A and B. The output will be 0, which indicate there is no signal in A and B. The output will be 0. Next one, A is equal 1 and B is equal 0. There is a signal in input A. The output will be equal to 1. For OR gate to give an output signal, there should be at least one input signal. The third input signal will be A is equal 0 and B is equal 1. Since there is a signal in one of the input, therefore the output will be equal to 1. The final input signal will be A equal 1 and B is equal to 1. Therefore, the output will be is equal to 1. Let's explore the AND gate, a fundamental digital logic gate. The AND gate output a 1 only if all of its inputs are 1. Otherwise, it outputs 0. Here is the truth table for the AND gate. When both inputs are 0, A is equal 0, B is equal 0, the output is 0 because neither input is high. When A is equal 1 and B is equal 0, the output is 0 because not all inputs are high. When A is equal 0 and B is equal 1, the output is 0 since not all inputs are high. When both inputs are 1, A is equal 1 and B is equal 1, the output is 1 as all inputs are high. In summary, the AND gate outputs 1 only when all inputs are 1 and 0 otherwise. Next, we will see how NOT gate works. An inverter or NOT gate is one that outputs the opposite state as what is input. It has only one input and one output. If you provide an input signal is 0, the output will be 1, and if you provide an input signal 1, the output will be 0. Let's explore the NOR gate, which is a combination of OR gate and NOT gate. The NOR gate outputs a 1 only if all its inputs are 0. Otherwise, it outputs 0. Here is the truth table for the NOR gate. When both inputs are 0, A is equal 0 and B is equal 0, the output is 1 because neither input is high and no inverts the O result. When A is equal 1 and B is equal 0, the output is 0 because at least one input is high, so the no output becomes 0. When A is equal 0 and B is equal 1, the output is 0 since at least one input is high and no inverts the O result to 0. When both inputs are 1, the output is 0 because both inputs are high and no inverts the O result to 0. In summary, the NOR gate outputs 1 only when all inputs are 0 and 0 otherwise. Let's explore the NAND gate. It's a combination of AND and NOT gates. The NAND gate outputs a 0 only if all of its inputs are 1. Otherwise, its output 1. Here is the truth table for the NAND gate. When both inputs are 0, the output is 1 because not all inputs are high. When A is equal 0 and B is equal 0, the output is 1 because not all inputs are high. When A is equal 0 and B is equal 1, the output is 1 since not all inputs are high. When both inputs are 1, A is equal 1 and B is equal 1, the output is 0 as all inputs are high. In summary, the NAND gate outputs 0 only when all inputs are 1 and 1 otherwise. Let's explore the exclusive OR gate. The exclusive OR gate outputs a 1 only if the inputs are different. If both inputs are same, it outputs 0. Here is the truth table for the exclusive OR gate. When both inputs are 0, A is equal 0 and B is equal 0, the output is 0 because both inputs are same. When A is equal 0 and A is equal 1 and B is equal 0, the output is 1 because the inputs are different. When A is equal 0 and B is equal 1, the output is 1 since the inputs are different. When both inputs are 1, the output is 0 as both inputs are the same. In summary, exclusive OR gate outputs 1 only when the inputs are different and 0 when the inputs are the same. Let's explore the exclusive NOR gate. The exclusive NOR gate outputs a 1 only if the inputs are the same. If the inputs are different, it outputs 0. Here is the truth table for the exclusive NOR gate. When both inputs are 0, A is equal 0 and B is equal 0, the output is 1 because both inputs are the same. When A is equal 1 and B is equal 0, the output is 0 because the inputs are different. When A is equal 0 and B is equal 1, the output is 0 since the inputs are different. When both inputs are 1, the output is 1 as both inputs are the same. In summary, the exclusive NOR gate outputs 1 when the inputs are the same and 0 when the inputs are different. That's all about logic gates. These gates are the foundation of digital electronics used in computers, circuits and all digital devices. Thank you for watching.